xfy minus yfx. So we can see a position vector and a force vector. They are in the xy plane, right? That's why we're writing x and fy, but they are in the xy plane. So the direction of torque, yes, torque will act on z-axis because they are in the xy plane. Therefore, torque will act perpendicular to both. So this is how we write torque in Cartesian coordinates. Okay, see, now we can write this F as mass into acceleration. This is m a y component of acceleration minus y, and for fx we can write m a x. Okay, so this can be written as m, acceleration is dv by dt. Okay, so we can write d vy by dt minus, bracket close, minus y, start the bracket, m, here we'll write d vx by dt, bracket close. Okay, m is a constant, and you can see that we have m in both the terms, so we can take m outside, and in the bracket we can write x dvy by dt minus y dvx by dt. ठीक है? अच्छा, what if I take d by dt of x vy? Then we can write this dx by dt into vy plus x into dy by dt. This is how we can write. And dx by dt is vx. So we can write this as vx vy plus x dvy by dt. Similarly, if I write d by dt of y vx, then this is dy by dt into vx plus y into dvx by dt. This dy by dt is vy, right? vy vx y dvx by dt. So you can see that इसमें और इसमें, है ना, अगर हम ये प्लेस करते हैं, ये लिखते हैं, इफ यू राइट दिस, तो हमारा vx vy, बिकॉज वी हैव अ नेगेटिव साइन हियर, तो ये हमारा वैसे भी कैंसिल हो जाएगा, ये vx vy है, और जब इसको हम यहाँ लिखेंगे तो ये माइनस vx vy होने वाला है, तो अल्टीमेटली वी विल गेट 0 फॉर दिस टर्म, है ना, ये टर्म कैंसिल हो जाएंगी पेयर्स में बिकॉज वी हैव अ नेगेटिव साइन हियर, तो ये प्लस माइनस हो जाएगा और ये कैंसिल हो जाएगा. ठीक है, सो वी कैन राइट this as d by dt of x vy minus y vx. इस स्टेप में कोई प्रॉब्लम तो नहीं है? पक्का? क्यों किया, ये कैसे किया, क्या हुआ, सब क्लियर है? पक्का पक्का ना? ओके, अब देखो, अब इस m को वापस ले जाओ अंदर, तो d by dt x m v y minus y m v x. m v y is momentum along y axis, m v x is momentum along x axis. ठीक है, so we can further write this as d by dt, in the bracket we will write x p y minus y px. And what is this? See, how do we write torque? How do we write torque? Rate of change of angular momentum. So this is the expression for torque, and we are getting something like this. So torque is d by dt of what? Torque is d by dt of अरे बोलो। एल डी बाई डी टी किसका होता है वो डेरिवेटिव? एंगुलर मोमेंटम का होता है, राइट? तो ये आपका जो एक्सप्रेशन है किसका आ गया? एंगुलर मोमेंटम का. सो वी कैन राइट दिस डी बाई डी टी एल जेड. ठीक है, because the torque is along z axis, so we'll take angular momentum also along z axis. So we can write Lz as x p y minus y px. This is angular momentum along z axis. Similarly, we can write for x and y axis. Okay, I'm going to clear the screen. Okay, so angular momentum along z axis is x p y minus y px. Similarly, we can write for x axis. What should I write here? Y pz minus, बोलो, z पी वाई. बोलने से आपको आधा वैसे ही लर्न हो जाएगा. एंगुलर मोमेंटम अलोंग वाई एक्सिस इज z पी एक्स माइनस x पी z. ठीक है, राइट द हेडिंग पोलर कोऑर्डिनेट्स ऑफ एंगुलर मोमेंटम. See, for this, let's consider a particle at point K. K xy is the position of the particle of mass m. So we have a particle of mass m at K. Okay, and it is moving in this direction. This particle is moving in this direction. Vector v is the velocity of the particle, and vector p is the momentum of the particle. So we can write vector p as mv vector. Okay, and this particle is rotating in xy plane. This particle is rotating in xy plane. Position vector of the particle at any instant of time is vector r. And this position vector makes an angle theta with x-axis. Okay, so angle XOK is theta. So we can write x as, if we draw the perpendicular here, so we can write x as r cos theta, and y can be written as r sin theta. See, this is the line of action of P. We can draw the line of action of P. This is the line of action of P, right? This line is the line of action of P. And this line of action of P, it makes an angle phi with position vector. This is the direction of position vector, right? And this is the direction of momentum. So this line of action of P makes an angle phi with the position vector, and it makes an angle alpha with x-axis. Okay, इतना clear हो गया? So we can write x and y component of linear momentum also. So x component of linear momentum can be written as p cos alpha, while y component of linear momentum can be written as p sin alpha. ठीक है? Join this. This is the perpendicular on the line of action of P n. Okay, mark this point as n. Now, because we know that angular momentum, we can write angular momentum as, see, this object, this particle is rotating in xy plane. This particle is rotating in xy plane. So angular momentum, what is the direction of angular momentum for the particle which is rotating in xy plane? Z. So this is Lz. We can write this as xpy minus ypx. Now substitute these values here. X is r cos theta. Py is p sine alpha minus y is r sine theta. And px is p cos alpha. We can take rp common. And in the bracket we have cos theta sine alpha minus sine theta cos alpha. It's like sin a cos b minus cos a sin b. है ना, एक आइडेंटिटी होती है ना, sin a cos b minus cos a sin b is sin a minus b. So what is a here? If we compare this with this equation, a is alpha and b is theta. So this L can be written as rp sine alpha minus theta. Now look at this triangle. We have this angle alpha here, theta here, and this angle is phi. You can see that these two are vertically opposite angles. So if this angle is phi, this angle has to be phi only. These are vertically opposite angles. Now we can, in this triangle, look at this one. ये वाला triangle. Okay? We can apply exterior angle property. Exterior angle, sum of the interior angles. Exterior angle is the sum of the interior opposite angles, right? So this alpha is theta plus phi. So therefore alpha minus theta is phi. In place of alpha minus theta, we can write phi. See, or we can write this as p into r sine phi. Now what is r sine phi? This is r. है ना? So this line kn is r cos phi. Look at this triangle where we have angle phi. So this kn is r cos phi. And on is r sine phi. So we can write this as p into on. Okay? P into on. So L is the product of linear momentum P and perpendicular distance of line of action of P from the axis of rotation. Geometrical meaning of angular momentum. Please draw coordinate axis first. So this is our, let's say this is our x-axis, this is our y-axis, and this is the z-axis. Okay, so initially we are assuming that we have a particle and that particle is rotating in xy plane. So particle is at some point here, particle is here at this point k. Okay. किसी भी इंटरवल ऑफ टाइम में हम ये अज्यूम कर सकते हैं कि पार्टिकल जो है वो के पर है. ठीक है, सो वी कैन राइट द पोजीशन वेक्टर ओके एंड पोजीशन वेक्टर ओके इज, वी कैन टेक दिस एज वेक्टर आर. ठीक है, तो ओके वेक्टर is the position vector of the particle at a point of time. ठीक है, now in small time dt, the particle, this particle which is at a, in small time dt, let's say that it reaches at point L. ठीक है, it reaches at point L and now the position vector will change. So कितना टाइम लगा इसको यहां से यहां तक आने में? dt टाइम लगा. तो dt टाइम में स्मॉल डिस्प्लेसमेंट होगा, राइट? है ना, स्मॉल डिस्प्लेसमेंट इन स्मॉल टाइम, dr is the small time displacement in small time dt. ठीक है, now you can use triangle of vector addition and you'll get the position vector of the new position of the particle. This is vector r plus vector dr. So vector ol is the new position vector of the particle. So we can find the displacement vector as well. Displacement vector is vector kl. It is vector dr. ठीक है, you can subtract these two to get this. ठीक है, अब क्या करेंगे हम? We'll draw a parallelogram. We'll consider this as a part of parallelogram, and using this, complete this parallelogram. Okay, so this point is M. Okay, so we have formed a parallelogram. Now, area swept by the particle in time dt. So this is the area swept by the particle in time dt. Yes, this is the area swept by the particle in time dt, right? Kitna area cover kiya particle ne? So we can, because we have this particle has covered a small displacement in small time, so area swept is also small. So we can write area as dA vector. This is the area swept by particle. Area swept by the particle in time dt. Okay, so this is the area swept by the particle, and this is equal to, we can write area of triangle OAL. Now, in a parallelogram, diagonal divides the parallelogram into two triangles which are congruent, and congruent triangles have equal area. So these two triangles are equal in area. So, or we can write the area of triangle as half of area of parallelogram. Can we do this? So area of this triangle is half of area of parallelogram OALM. Okay, and how do we find area of parallelogram? What is the formula? Hmm? So in this case, we can write vector OK cross vector OM. OK is vector R and OM is equal to KL. OM and KL are the opposite sides of parallelogram. They are equal. So we can write dr for this. So half vector R cross dr vector. Any doubt? Okay, now what if we differentiate this area with respect to time? On differentiating area with respect to time, we get dA by dt. And this is equal to half vector R into dr vector by dt. Yes? And dr vector by dt is velocity. And how do we write velocity in terms of momentum and mass? Dr by dt is v, and v is vector p by. Okay, so in place of dr by dt, we can write this p by m. So dA by dt is equal to half vector R cross vector P by M. Because you can see now this is the vector product of displacement and linear momentum, and this M is a scalar. So we can write this M outside. So it's 1 upon 2M vector R cross vector P. And this R cross P is nothing but R cross P is, oh my god, it's angular momentum. क्या कर रहे हो? Angular momentum पढ़ रहे हो? R cross P is angular momentum. So we can write this as vector L by 2M. ठीक है? So from here we can write vector L as, no talking please, vector L as 2M, vector L as 2M dA by dt, and close this in box. ठीक है? अब इसमें क्या लिख सकते हैं हम? That angular momentum of a particle, please write this in a notebook, angular momentum of a particle about a given axis is twice the product of mass of the particle and aerial velocity of position vector of the particle. ठीक है? Mass of the particle and aerial velocity of position vector of the particle. See, this is area. A is area, dA is area, and dA by dt is aerial velocity. Yes? Aerial velocity. Show that the angular momentum about any given point, any point of a single particle moving with constant velocity remains constant throughout its motion. So we have a particle. Okay? This is the particle. It is present at point P and it is moving with some velocity vector v. Okay? This is the velocity with which it is moving. We have to find angular momentum about an arbitrary point. So we can consider that arbitrary point anywhere, and that point we can take किसी भी arbitrary point के about आपको angular momentum find करना है. तो let's choose a position. Let this be the reference frame, and here is the origin. ठीक है? And the position vector of this particle at this point of time, let the position vector be vector r. ठीक है? This is the position vector of the particle at a point of time, and it is moving with some velocity v. So we can see that when we stretch this r, then the angle between r and v is theta, and we write angular momentum as vector r cross vector p. P is mv, r cross mv vector, or we can write this as mvr sine theta. Any doubt? Clear है ये? ठीक है? What if I draw a horizontal line here and a vertical line? Now you can see that this angle is theta. Angle between r and v is theta. This angle is also theta. These are vertically opposite angles. Now we can resolve this vector r into rectangular and horizontal components. The horizontal component of vector r is r cos theta, and vertical component is r sin theta. Okay? Let this be k. And suppose OK is d. OK is equal to d. Okay, and this r sin theta is, we can write this r sin theta is mv. For r sin theta, we can write OK, and OK is d. So angular momentum is mvd. Now, if we assume that after some time, particle is moving in the same straight line, and after some time, particle reaches at some point q. Okay, we are given the same reference frame. Now, the position vector of the particle at this point will be, how will you write? See, we can draw like this. This is the position vector of the particle at this point of time. So we can take this position vector as vector r dash. It is clearly seen that vector r dash and r, they are not equal. R dash appears longer than r, no? Angle is also different. And again, because it was moving in the same straight line, so velocity is in this direction. We can stretch this. Now this time, let's say angle is theta dash. As we have taken r dash, in the same way we can take theta dash. This angle is theta dash, and because this is theta dash, this has to be theta dash. These are vertically opposite angles. Okay? Again, this was the angular momentum at P, right? In the same way, we can find angular momentum at some other point Q. Let the angular momentum be L dash at this point. Now, again, we'll write the same thing. Vector R dash this time, cross vector P. Okay? So, this is vector R cross M, because object is moving with constant velocity. It is given to us. So again, we'll write mv vector because it is moving with a constant velocity. This is m, dash है ना, m v r dash, क्रॉस प्रोडक्ट है तो एंगल क्या होगा, थीटा डैश है यहाँ पे, साइन थीटा डैश. ठीक है. नाउ लुक एट दिस ट्राइंगल ओ क्यू के. ट्राइंगल ओ क्यू के को देखो, वी हैव आर डैश, है ना. सो के क्यू इज आर डैश cos theta dash and OK is R dash sin theta dash. नहीं, ये ऐसे है ना. This angle is theta dash. This is R dash. This is O, K, and Q. We can resolve this in horizontal and vertical components and write this. Now this R dash sin theta dash is the same distance OK, है ना. So we can write OK in place of R dash sin theta dash. OK is D. So this is MVT. So we can see that in both the cases, angular momentum is same. ये prove करना था कि angular momentum remains constant throughout the motion. If the speed is constant, if the velocity of the object is constant, then angular momentum is also constant. Please read the question first. See, here we have, children, please listen. यहाँ पे क्या है? What will be the duration of the day? So what is the duration of the day? It's 24 hours, right? Earth completes one rotation in 24 hours. So what will be the duration of the day if Earth suddenly shrinks to 1/64th of its original volume? Mass remaining unchanged. We are not changing the mass, we are only changing the radius of the Earth. Okay, so this is the present size of the Earth, and after shrinking, this is the size. Okay, so let the present volume be V1. ठीक है, और shrink होने के बाद volume क्या हो गया, V2. Radius is R1 और shrink होने के बाद radius क्या हो गया, R2. Time period of rotation अभी क्या है, T1, it's 24 hours, and shrinking के बाद time period will change to T2. We know that angular momentum remains conserved. Angular momentum remains conserved. ठीक है. See, if the Earth suddenly shrinks to 1/64th of its original volume, we are not changing the mass. Only volume is changing. So we can write that V2 is 1/64 V1, and Earth is a sphere. We can assume Earth to be spherical in shape. So how do we find volume of a sphere? It's 4/3 pi r cube. So we can write 4/3 pi r1 cube is equal to 1/64. In the bracket, we will write 4/3 pi, sorry, this is R2, right? Pi R1 cube. 4/3 pi cancel हो जाएगा. We are left with this R2 cube is equal to 1/64 R1 cube. Or we can write this as 4 4 the 16, 4 the 64, है ना? 1/4 R1 whole cube. Now on comparing these two, we get R2 as 1/4 R1. ठीक है? So radius becomes 1/4 of the original radius. ठीक है? एक चीज समझ आ गई? अब हमने क्या करना है? There is no external torque acting on the system. Since there exists no external torque, write this. You have to write this. Acting on the system. Therefore, angular momentum is conserved. ठीक है? अब क्या करेंगे? How do we find angular momentum? Angular momentum is I omega. Do we have angular speed or angular velocity of the planet? No. We have time period. Can we relate omega with t? What is the relation between omega and t? It's 2 pi by t. ठीक है, I into 2 pi by t, this is a constant. And see, because 2 pi is a constant, so we can write I by t is a constant, right? है ना? अच्छा, moment of inertia of a sphere, we don't know क्या होता है? For sphere, solid sphere, it's 2 by 5 mr square. I is 2 by 5 mr square. ठीक है, ये हमें पता होना चाहिए. ठीक है, अब because I by t constant है, so we can write I1 by t1 is equal to I2 by t2. What we have to find? We have to find the value of time period, है ना? So we have to find t2. We can write this as I2 by I1 into t1. Can we write like this? This I2 by I1 now. I2 is 2 by 5 m R2 square and I1 is 2 by 5 m R1 square into T1. 2 by 5m, 2 by 5m cancel हो जाएगा. ठीक है? Where do I write now? I'm going to erase this. Should I? ये erase कर दे. So T2 is R2 by R1 whole square into T1. R2 by R1 is, from here we can find R2 by R1 as 1 by 4. So we can write 1 by 4 whole square into T1 is 24. हाँ जी, बताओ क्या आंसर आ रहा है? 3 by 2. Or in decimal we can write 1.5 R. So this is your answer. ठीक है? Easy? Difficult था? छुट्टी कर लो. अच्छा ये. हाँ, संडे तो क्लास नहीं है. Okay, read the question. बेटा ऐसे टीचर मिलेगा आपको जो कह रहे छुट्टी करो पढ़ लो 4-5 घंटे. हम कह रहे हैं हम नहीं पढ़ते. जाने वाली है चेयर. चेयर भी जाने वाली, लैपटॉप भी जाने वाला है, फोन भी जाने वाला है, रूम भी जाने वाला है. रूम को आपकी 12th से पहले पहले रूम को चेंज करना पड़ेगा. क्या सेल? नहीं, रूम को भी पेंट करवाने की जरूरत है. 30,000 मैं बेटा 16 लूंगी, मैं नहीं लूंगी. इस चीज से स्लो होगा. मैं 16 लेने का सोच रही हूँ. ले लो. ये जाएगा और 16 में. प्रो और प्रो मैक्स में स्क्रीन का तो डिफरेंस है नहीं ज्यादा. थोड़ा सा ही है 0.6 का. Okay, read the question now. Children, please read the question. Two disks of moment of inertia I1 and I2 about their respective axes, normal to the disk and passing through the center and rotating with angular speeds omega 1 and omega 2 are brought into contact face to face with their axis of rotation coincident. ठीक है? Show that angular speed, calculate angular speed of the two disk system and show that the kinetic energy of the combined system is less than the sum of the initial kinetic energy of the two disks. And how do you account for the loss of energy? Take omega 1 not equal to omega 2. बताओ भाई कैसे करेंगे? सो इनिशियली हाँ बिल्कुल ठीक कर रहे हो. देखो यहाँ पे क्या है बहुत ध्यान से देखना है. वी हैव टू डिफरेंट डिस्क. ओके, डिस्क 1 एंड डिस्क 2. Okay, their moment of inertia is given. Moment of inertia of disk 1 is I1 and that of disk 2 is I2. Angular velocities are given. Its angular velocity is omega 1. Its angular velocity is omega 2. We can write their angular momenta. Angular momenta L1 is I1 omega 1. Angular momentum of disk 2 is L2. It's I2 omega 2. Now we can write the total angular momentum of the system. ठीक है? So total angular momentum is denoted by L and it is equal to I1 omega 1 plus I2 omega 2. Okay? See, अब इसमें क्या है? They are brought into contact face to face with their axis of rotation coincident. So their axis of rotation is coincident and they are brought into contact face to face. So we can write the angular moment of inertia of the two disk system. Okay, so moment of inertia of the two disk system is I1 plus I2. Okay, if we assume that they are moving with the same angular speed omega, so omega is the angular speed of the combined system. Angular speed of the combined system. Okay, so we can write angular momentum as L dash. It is I1 plus I2 omega. ठीक है? यहाँ पे कोई external torque act हो रहा है? No. So we'll write is as there exists no external torque acting on the system. Therefore, L and L dash are equal. ठीक है? So we can write I1 omega 1 plus I2 omega 2 is equal to I1 plus I2 omega. So from here we can find the value of omega. We can write omega in terms of these variables. Omega as I1 omega 1 plus I2 omega 2 divided by I1 plus I2. This is the angular speed of the combined system. Okay. तो फर्स्ट पार्ट में आपको एंगुलर स्पीड फाइंड करना था, तो ये हमारा फर्स्ट पार्ट हो गया. नाउ वी हैव टू फाइंड काइनेटिक एनर्जी ऑफ द कंबाइंड सिस्टम एंड सम ऑफ we have to prove that kinetic energy of the combined system is less than the sum of the initial kinetic energies of the two disks. So we can write initial kinetic energy first. So what is the initial kinetic energy? Initial kinetic energy, how do we write kinetic energy? In translational motion, half mv square, and here we'll write half I1 omega 1 square. mv square होता है ना, I1 omega 1 square. This is for disk 1. Similarly, we can write for disk 2. So this is the initial kinetic energy. In the same way, we can write final kinetic energy as half moment of inertia of the combined system is I1 plus I2. And angular speed of the combined system is omega square. Now in place of omega, we can write this. ठीक है, कर सकते हैं ना? ये क्या हो जाएगा? half I1 plus I2 And for omega, we are going to write this. I1 omega 1 plus I2 omega 2 upon I1 plus I2 whole square. देखो यहाँ पे भी in the numerator we have I1 plus I2, in the denominator as well we have I1 plus I2 square, so cancel हो जाएगा एक, और we can write half I1 omega 1 plus I2 omega 2 square. In the denominator we can write I1 plus I2. So this is the final kinetic energy of the system. We have to prove that kinetic energy of the combined system, that is EF, it is less than the sum of the initial kinetic energies of the two systems. This is what we have to prove. For this, we need to subtract these two and see what do we get. Okay, let's see. So for this, we'll subtract these two, EF minus EI. So EF, or we can do EI minus EF because there is loss of energy, है ना? तो loss of energy है, तो we should always subtract, greater quantity, smaller quantity from greater quantity, right? Because there is loss of energy, है ना? Loss of energy अगर हम assume करके चल रहे हैं, initial बड़ा होगा इसका मतलब, है ना? और final छोटा होगा, तो we can write like this, ठीक है? EI minus EF, so this is half I1 omega 1 square plus half I2 omega 2 square. This is your EI minus half EF is I1 omega 1 plus I2 omega 2 whole square divided by I1 plus I2. Now on solving this, see, you can take the, you can write 1 here and cross multiply this, है ना? After taking the LCM and simplifying, what will you get? I'm writing the final expression. Should I? करना एक बार solve करके देखो क्या आता है. Answer. Final answer is I1 I2 in the bracket. We will write omega 1 minus omega 2 whole square. In the denominator, we have 2 I1 plus I2. So we can see that we have omega 1 minus omega 2, but we are taking the square of this. So we have something which is greater than 0. Right? I'm going to erase this. ठीक है? If this is greater than 0, it implies that EI minus EF is greater than 0, or we can write EI greater than EF. है ना? इससे क्या मतलब है कि initial kinetic energy of the system is greater than final kinetic energy, which indicates that there is loss of kinetic energy. ये loss क्यों हुआ? This implies there exists loss of kinetic energy. And loss क्यों है? It must be due to friction between the discs. है ना? जो discs हमने contact में place किए हैं, वो उसमें frictional force की वजह से हो सकता है. Must be due to friction in the contact of the two discs. देखो जो ये friction है, ये सिर्फ ये internal to the system है. It is not external. ठीक है? तो अगर फ्रिक्शन से कुछ लॉस हो रहा है तो इट इज इंटरनल टू द सिस्टम. उससे एक्सटर्नल टॉर्क 0 ही रहेगा आपका. एक्सटर्नली तो कुछ नहीं कर रहे हो ना, विद इन द सिस्टम लॉस हो रहा है, अपने आप सिस्टम के अंदर लॉस हो रहा है, तो उसके लिए तो हम रिस्पॉन्सिबल नहीं है, बाहर से तो हमने कुछ नहीं किया. ठीक है? क्लियर? कुछ पूछना है इस पे? डाउट ही नहीं होते, बड़े इंटेलिजेंट